Hey, what's going on everybody? In this video, we're going to create a working digital clock using C. Here's what it looks like. Let's get started. To kick off this project, we'll need a few imports. We'll do some copying and pasting. Along with the standard input-output header file, we'll also need the time header file to work with time-related functions. We'll also need standard bool, std_bool, to work with booleans. And then UNISTD, meaning Unix standard. This header file will provide a sleep function to make our program wait for 1 second before updating the time. Here's the imports we'll need. Now we need to declare our variables and other data structures. This first variable, it's going to have a data type of time_t. The variable name will be raw time, and I'll set that to be 0 right away. This variable of raw time, it's going to hold a number of seconds. The reason I'm not using an integer, it's because we need a very big integer. In fact, a long. There's a limit to how big an integer is. It's a number just over 2 billion. But if we use a long, or more specifically, this type of time t, we can hold a number that's even bigger than that. This data type of time t, it specifically holds what is known as Unix epoch. We use epoch as a reference point. It's usually some date around January 1st, 1970. We'll measure how many seconds have passed since this date. Depending on when you're watching this, it's a number around 1.7 billion. 1.7 billion seconds has passed since this date, and we'll use it as a reference point. This is the epoch. This date, January 1st, 1970. The next thing we'll need is a struct, but not just a struct, a pointer to a struct. There's a struct provided to us from the time header file. The data type is struct, the tag name is tm, meaning time. This will be a pointer, we need the dereference operator, and we'll name this variable pTime. Since the struct isn't using the typedef keyword, we do have to type struct. If it was using the typedef keyword, we wouldn't need that keyword as struct. However, we do in this case. pTime is going to be a pointer. If we declare a pointer but don't assign it, it could contain a garbage value. So what you could do with pointers is set them to be a value of null. Null meaning no value. But be sure that you don't dereference it before assigning it. Don't later in your program dereference it while it's still null. That can cause a segmentation fault. Dereferencing a null pointer is very dangerous and can lead to unexpected behavior. Then the last thing we'll need is a boolean of is running, and we'll set that to be true right away. We'll continue the digital clock while the program is running. Then once we have our variables and other data structures, let's create a welcome message. We'll just print the title, digital clock, new line. Then we need a while loop. While our condition is running. What other programmers might do is say while true, which you could do, but I don't like doing that just because it offers less control of the while loop. Then at any point within this program, we can say is running equals false to exit. But that's my own personal preference. So while is running, continue the program. We need this while loop to execute some code approximately every second. Well, we could use the sleep function. Now, if you're on Linux or Mac, you can use sleep and then pass in 1 to sleep for 1 second. And then let's print something just to test it. Printf, I'll just print the word test. New line. And this does work for me. Every second, we're printing the word test. But if you're a Windows user, you may have to use a different function if this doesn't work. You may need a different import. Windows.h. This function instead is going to be sleep with a capital S. Then you pass in 1000 milliseconds rather than seconds. So if you're on Windows, you may have to use this function instead. I'm on Windows, and the reason that both work for me is that the sleep function is actually provided to me by my compiler. If you're on Windows and this version of sleep doesn't work for you, then you may need to use the sleep function with a capital S, then pass in milliseconds rather than seconds. But again, it depends on your compiler. Alright, our while loop is working. We're printing something, and then sleeping, and then we're doing that forever. Now what we're going to do is update the time, our raw time variable. If we call the time function, we can update our time variable, but we have to pass in a pointer or an address. We're going to pass in the address of our raw time variable to update it, so that it's passed by reference rather than passed by value. We're going to update the time with the current time, whatever it is. And then let's print it to test it. Printf. Since our raw time is a different type of integer, we have a different format specifier. That is LD, meaning long decimal. Then I'll add a new line. We will display our raw time variable, and it should be a very large number. Yeah, you'll get like 1.7 billion seconds or so. But it is updating every 1 second though, which is good. This is the amount of time in seconds that have passed since our reference point, that epoch, January 1st, 1970. 1.7 billion seconds has passed since then. But we can use that as a reference point to calculate the current time. Alright, we know that we're updating the time every second. But now we have to display it in a readable format. Here's how. We can use our time struct. Our time struct contains a bunch of members that represent the year, month, day of the week, hours, minutes, seconds, and so on. We will assign our pointer of ptime equals, call the local time function, and then pass in the address of our raw time variable. Pass in the address of our raw time variable. This function is going to return a pointer. It's going to return a pointer to a time struct that contains those fields of hours, minutes, and seconds. We're finishing assigning this struct, because originally it was null. Our pointer of time should point to a time struct, and it contains the current time. Now we just need to print it. Here's how. Let's start with a printf statement. We'll display 3 digits, each separated with a colon. We'll do a little bit of formatting in a moment. We have a pointer of time. To access a member of a struct, normally you would type a dot, that's the access operator, followed by the member name. In this case, we have tm_hour. But what we have to do is dereference this pointer and then access one of its members. Kind of like this. However, there's an order of operations. We would end up accessing this member first of this memory address and then dereferencing it. So we would need to dereference this pointer first and then access the hour. But there is a shortcut too. Rather than using the dot, you can use the arrow operator. It's a shortcut. That'll do the same thing, and it's more readable. Dereference our pointer, then give me the current hour of our time struct. And then let's do this with the other members. Take our pointer to our time struct, dereference it, and access tm_, just min for minute. Again, take our time pointer, dereference it, and access tm_sec for seconds. We should have the hours, minutes, then seconds. Oh, and then we need a new line. Here we go. Currently it is 7:16 and some seconds. Let's add some zero padding. After the format specifier, type 02 to add 2 spaces of zero padding. And that looks a lot better. We're zero padding these digits. After each second, we're printing the new time on a new line. What if we could edit it in place? Here's how. Rather than printing a new line in printf, we'll go back to the beginning and use \r for carriage return. We'll end up moving the cursor back to the beginning and reprinting something. And now our time should update in place, because we're moving the carriage back to the beginning. Alright everybody, and that is how to create a digital clock using C.